My name is Neil Stringfellow. I am the Executive Director of iVEC. iVEC is a joint venture of 4 universities, public universities in Western Australia, and the CSIRO. And we are in charge of the Pawsey Centre, for the management and operations of the Pawsey Centre, and for our community, for our partners, we are responsible for providing services in supercomputing, in data, storage, analytics and management, and in visualisation. Our funding coming from the Western Australian government for operations, and particularly for a lot of our staffing, means we have a focus on our Western Australian partners. In particular, there is a focus on a couple of areas: geosciences, nationally significant and significant at the state level, and radio astronomy. Radio astronomy in particular because of Australia's bidding for the square kilometre array. So the Pawsey project is an $18 million project, Commonwealth funding. iVEC was able to demonstrate to the Commonwealth government that it was going to be perfectly capable of managing and operating a world-class facility. And therefore, Pawsey Centre was granted to iVEC for its management and operation. And the Pawsey Centre building is of the order of $30 to $35 million of investment. A wonderful investment at that, including some very innovative technologies in terms of cooling and in terms of its green credentials.
CSIRO is the nation's premier science agency. The CSI Geothermal Project has developed a groundwater cooling solution for the Pawsey Centre supercomputer. This system uses ambient temperature water from an aquifer 150 metres below the surface. The water is pumped to the surface and run past a heat exchanger to extract heat from a supercomputer before it is returned to the aquifer, slightly warmer with no net water loss. The water savings alone are estimated at 38.5 million litres a year.
A key aspect of making that data valuable is making it available, and to that end we have built a dedicated iVEC network which provides a 10 gigabit per second link between the 5 partners and their various facilities. So for example, a researcher may wish to create a fluid dynamics simulation of a vehicle such as a car. This simulation would typically start in the I/O cell, where they would use our data analysis engines to create the background mesh on which their simulation would run. Once the mesh is created, it would be transferred across the iVEC network to the supercomputer, to Magnus in the supercomputing cell. And on Magnus, the researcher would run that computational fluid dynamics simulation using the capabilities of the petascale facility. Once the simulation had finished, the large output data sets that would typically be produced by such a simulation would be transferred back to the I/O cell, where the raw data could be translated into more meaningful results, such as a visualization of the vehicle and the flow over it, or other measurements of pressure, velocity, and so on. Once the researcher had completed that post-processing analysis, they would typically archive their results onto our tape store, where the data would sit available for reuse and for other researchers to see what they had done with their simulation.
In a couple of decades, we will have harvested all of our energy and mineral resources that is readily available at the surface. We're now looking in this National Research Science Precinct for the future of geosciences, for future energy and mineral resources. Currently, we are on the Pawsey Stage 1, and we're using the facilities for mainly big data assimilation, visualization, and for sustainability research.
Pawsey effectively becomes part of the SKA, part of the telescope. We have to have high-performance computing plugged right into the data flow from the telescope, because there's so much data flowing, we have to process it in real time. We can't afford to stop and collect it and store it and think about it later. Supercomputing has to be plugged right into the very fabric of the telescope itself. The Pawsey is the machine which is going to catch the data and turn the data into this interesting new view, this amazing new view of the universe. Without Pawsey, none of this is going to be possible. And it's somewhat humbling to think that Pawsey, as it stands today, is only 1% of the machine that's going to be there in probably 10 to 15 years from now to deal with the whole SKAs.